we'll be discussing controlling the layout. When we think about Matplotlib, I always think about my figure and my axes. But even before we dive into the Matplotlib, let's talk a little bit about pandas. It's probably the most widely used data analysis package in the world, if I had to guess. And pandas has pretty convenient plotting methods. I can just call data.plot and I magically get, all of my columns as different lines. I get a nice legend in the lower left here. It's great. But if I wanted to do anything slightly more complex, if I wanted to, say put these lines on separate plots, now I have to work within the confines that pandas has given me. I have to use the subplots equals true argument, and I get my lines on different sets of axes. And even more so, I can follow this up by slightly changing my layout here. Instead of a 2-row layout, I'll have a 2-column layout. And when I run this, I get 2 plots on 2 different sets of axes. And I still have the legends. We can remove those and spruce things up. But what pandas ultimately does is it limits your ability to create effective visualizations because you have to work within the scope that it has provided you, within the lens into Matplotlib or whatever plotting backend that it's using. So I always like to explicitly lay out my figures instead of letting pandas do all of the work. It's great for conveniences, and if you're just doing one-off exploratory analysis, perfectly fine. But with Matplotlib, we always start with the figure. And in fact, the figure is your sheet of paper. It's your canvas that you draw on. And what do you most commonly draw when you're thinking of graphs? Well, you draw sets of axes, a set of an X and a Y axis. That's our set of axes. And so when we want to position our axes on a sheet of paper, we have 2 choices, essentially choices that we can make, or 2 approaches we can take. We can add the axes based on a coordinate system, and this coordinate system is the proportion of the figure. And so these first 2 coordinates are the lower left-hand corner where my set of axes will exist, and then these second 2 coordinates are the width and height of that set of axes. So here you can see I've just set one that takes up pretty much my whole sheet of paper. Additionally, I can set more axes anywhere I want. This is a quick and easy way to create an inset axes. Although Matplotlib does have convenience methods to work with this, I can place axes pretty much wherever I want with this. Now, that's probably the most flexible way that you can add axes to a figure. But my preferred method is to use the grid layout system. Matplotlib has these convenience methods called add subplot on its figure, and you can essentially specify a grid. In this case, it's a 2x2 grid, and I've told Matplotlib that in my 2x2 grid, I just want a set of axes in the top left-hand corner here. That's what that 1 refers to. If I were to change this to a 2, we would see that my set of axes then appears in the top right. We can also create a set of axes that spans across rows or across columns. In this case, I'm spanning across the top row by specifying my index 1 and 2 on my 2x2 grid. That's great, but there's an even better way, in my opinion, and that is through the grid spec. What I'm doing here is I'm setting up an object that is aware of how many rows and columns it has. And instead of having to do this nonsensical indexing 1, 2, or 1, 3 if I wanted a columnar set of axes, I can use slicing notation. I can simply say, from my 2x2 grid, I want this set of axes to span all of my rows in the first column. And you see here that we get exactly that. And if I wanted to link this into into pandas, I don't have to let pandas dictate what axes it will draw on. I can actually pass the axes that I want it to draw on. And so when I set up my axes with my grid spec here, I can tell pandas draw on that axis, and that is where my plot will go. And so this is one of the ways that you can take a little bit control over your plots while still using some of the great conveniences that plotting from data frames actually offers. I also want to iterate that layouts are also useful as a form of communication. And so if we were to take some random data and create pretty much a dummy set of linearly organized points, we can see a slight relationship here amongst these scatter plot in the scatter plot. We can see that if I were to draw a regression line through it, it would probably go somewhere up and to the right. And in fact, when we do calculate the regression, we see just that. And so what we can see here is actually, useful insight. We say, whatever my x is, I'm assuming that my y will be, I believe the slope was about 3, right? 3 times x plus whatever the intercept here is, I believe it's about 10. And so this gains us some insight into our data. What's going on? How can we possibly predict an unseen value from this data set? But what's missing here are some of the assumptions about a linear regression. Some of the assumptions that I make about my variables being normally distributed. I haven't even talked about heteroscedasticity, but that's for another talk. But what we can do is we can actually examine the distributions underlying my x and my y points. And so what that would typically look like is I would start by creating more axes. And I use this shortcut of mosaic and subplot mosaic to lay out these axes. And all I'm doing is the same thing as a grid spec pretty much, except I'm applying semantic labels to the positions of my axes. And what this returns is not just an array of axes like we've seen before with subplots, but a dictionary of axes. And so in this set of axes, I will receive a key in my dictionary called top, and that will point to the set of axes in the top left-hand corner. Main will refer to the bottom left, and right will refer to the bottom right. And so when I do this, and I plot my scatter plots on my main plot, we see here that I do in fact have 3 plots. And note, in my mosaic, there was a dot in the top right, and that's a shorthand for telling Matplotlib to, I don't want any set of axes here, please don't put one. And so we end up with only 3 plots, or 3 sets of axes, I should say. And we see that we have my regression line, my scatter plot in the bottom left. Great. What do I do with the top and right though? Well, on the top, I can plot a histogram of my x values, and so this is just the univariate distribution of all of my x's, and I can see here from the shape that it's pretty much normal, and so we're probably good, at least in terms of the x's, or predictors, to use a regression. Now, what I can also do is I can plot my y's, and when I plot my y's, I can also make a histogram just like I did with the x, and what you see here is a histogram of my y's, also normally distributed. But one issue is that these y's aren't really lined up with anything, right? It's kind of convenient, right? When I look at the scatter plot and I see the histogram of the x's right above it, those x-axes are actually aligned, and so I can actually map, right, the distribution from the points to the actual univariate distribution or histogram above. What I can do here is I can add this orientation equals horizontal to my call for histogram, and it will actually transpose my right axes, and so I end up with a sideways histogram. Now this is a little bit better because now I'm able to more clearly map the location on the y-axis of all my scatter points onto this histogram. But there's something even better that we can do here. We can play around with the spacing, right? You see here that there's a lot of empty space between my histogram and my axes, and my main axes there in the bottom left. And so what we like to do with these types of plots is actually reduce that spacing so there is none. And what we can also do is that I'm really more so interested in the regression. The histograms are nice to have because I can see that my assumptions are met when I'm doing this type of modeling, but what I'm really focused on is highlighting that linear regression. And so in my 2x2 grid that I've created with the mosaic, I can actually tell Matplotlib to say, make my first column twice as wide as the second column, and at the same time, make my second row, right, the bottom row, twice as tall as my top row. And so when we combine this, along with eliminating the white space between these plots, we end up with something just a little bit nicer, easier to look at. And now my histogram is really closely, it's flush with my scatter plot and my regression line, just allowing me to make that connection between the actual data points and the histograms a little bit easier. One final thing that we can do here is to actually turn off the axis for our histograms, and that removes all of that visual noise around the histograms, because we don't really need the x's or the y values repeated, since they are already on the outermost portion of my scatter plot. And so we can use a layout actually as a means of communicating something efficiently, because I'm not only communicating that there's a linear relationship between my x's and my y's, but I'm also saying, look, my underlying univariate distributions of my x's and y's are both normal, and that gives me just a little bit more confidence that a linear regression is appropriate to use here. Additionally, we can also use layouts to create zooms. And so what this would look like is, if I have some data and I want to, this is date-time data, and I'm going to go ahead and just plot all of it on the lower axis here. What you can see is my data ranges over about a year and 10 months and some change. And what I can do here is I can just plot a subset of that data, just on top, right? So instead of focusing on the full year and 10 months, I can focus on a subset that goes from the 9th month of 2020 to the 4th month of 2021. But that's not as effective, right? I really have to look at this plot to be able to determine, well, what's going on here? Why are there two plots on top of each other? Why are the x-axes different? What we can do is we can add just a little bit of annotation here to highlight a specific portion of our main plot. And what else I will do is also apply that same highlighting color to my above plot. And now we gain a little bit of insight why these two plots are laid on top of each other, because I'm able to highlight the section of my long timeline right on my bottom plot and apply it to my upper timeline on my upper plot. Now, there are ways to actually connect these two plots. I could draw lines from this upper right point on this box to the bottom right of my upper plot here. However, this is actually one of the harder things that Matplotlib doesn't have a lot of conveniences for. And so in order to do this, it does require a lot of code, and I didn't want to bog you down today with just looking and skipping through Matplotlib code and just being like, oh yeah, it does this. But what I want to convey to you is that you can use these techniques, these control over your layout, to highlight different portions of your plotting data. Additionally, we discussed earlier that we can inset axes. We can have one parent axis and we can put another one in. What's great about this is if you use Matplotlib's convenience method to actually inset them instead of drawing them both on the figure separately, they are aware of each other, and you can actually use a fantastic convenience method, indicate zoom here, and if you do this, you're actually able to place a set of axes, and you're able to plot the same data except within a restricted x and y range, and you can then use a bounding box to actually zoom in on that interesting part of your data. So if you have very sparse data and there's only a few areas that you really, really want to highlight, you can use this method in order to demonstrate what, when I'm looking at this, where should I look if I'm not familiar with this data? And so you can use inset axes and zooming as mechanisms to point your audience in the direction of where they should look and help highlight the message that you have to convey. And that is how you can use layouts to make it pretty.